All right, guys, let's do two more problems from this homework. On this video, I'm going to do problem number 5 and number 7. These ones are a little bit trickier because while we're using the same equation, energy equals mass times specific heat times change in temperature, I'm not just going to give you three values to multiply together. I'm giving you energy and two other values, and you must solve it using algebra. Let's jump right in. Okay, problem number 5. 81,600 joules of heat energy is absorbed by 460.5 grams of copper metal. How much does the temperature increase? So let's get to it. Now, this is going to start the same way as you all do any algebra problem, and that is we're going to start by writing down the equation. All right, the energy absorbed is equal to the mass of the substance times its specific heat times its change in temperature. So let's plug in what we can from this problem. All right, so reading this 81,600 joules of heat energy. 81,600 joules of heat energy. So they've given us the heat energy 81,600 joules of heat energy. All right, let's see what else we can pull from this. Is absorbed by 460.5 grams of copper. Grams, that's mass. 460.5. So the mass is 460.5. Let's see what else we can pull from this problem. How much does the temperature increase? So they want to know how much the temperature changes when it absorbs that energy. That is delta T. So we are trying to solve for the change in temperature. That is what we are trying to solve for. A change in temperature. That means the last thing we need is the specific heat. Now, like with the last problems, the description here doesn't come out and just tell you what the specific heat of this substance is, but what it does tell you is that it's copper metal. And that's all the info you need. If you know it's copper, you can find the specific heat. And here it is, 0.385. All right. So the specific heat is 0.385. It takes 0.385 joules to raise a gram of copper by 1 degree Celsius. That's what it means. Okay. So now we got ourselves some algebra. We are trying to solve for the change in temperature. Now, guys, solving means getting the variable by itself. All right, getting the variable by itself. All right, so as we can see, the variable is not by itself. It's being multiplied by 460.5, and it's being multiplied by 3.385. So you have to undo this. Now, the way you undo multiplication is division. All right, so we are going to divide both sides by 0.385. Done. And we're going to divide both sides by 460.5. Okay, and now I'm just going to plug this into my calculator. I am going to take 81,600 and divide it by 0.385 and then divide it again by 460.5. And the answer I get is, 460.3. All right, so I get, for a change in temperature, 460.3 degrees Celsius is how much the temperature changes. So I'm going to go plug that in here, and I'm going to see if that is correct. Let's see. So 460.3, that is correct. So the temperature increases by 460.3 degrees Celsius. All right, great. That's how you do it. Let's do one more problem together. All right, I'm going to do number 7. All right, here we go. Let's see here. Now, you know what? I am going to skip number 7 because that's just another one where you're trying to find the heat energy. I'm going to do number 8 for you. Let's do number 8. An unknown metal sample needs to be identified. And you've decided to do so by finding its unique specific heat. This is, by the way, something that actually works. If you can calculate the specific heat of a substance, then you can just compare it against a chart here and figure out what the substance is, right? Like silver and tungsten are both metals, as is iron. They all look shiny, hard, and grayish. How can you tell the difference? Well, if you can calculate their specific heat in a problem, then you know what it is because all of their specific heats are quite different. So this is a real thing that people do. All right. So here we go. An unknown metal sample needs to be identified, and you've decided to do so by finding its unique specific heat. A 1,324 gram sample is heated with 15,600 joules of energy, and its temperature increases by 72.5 degrees Celsius. What is that substance's specific heat? So, as one does, we are going to write down the equation, all right? The energy something absorbs is equal to its mass times its specific heat times its change in temperature. So let's plug in what we can figure out. All right, let's see here. We have a 1,324 gram sample. 1,324 is the mass. All right, let's see what else we can pull from this. It's heated with 15,600 joules of energy. So 15,600 is the energy. 15,600 joules is the energy. All right, let's see what else we can pull from this. La 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 la. Its temperature increases by 72.5 degrees Celsius. All right, so the change in temperature is equal to 72.5 degrees Celsius, which means by process of elimination, the thing we're trying to solve for is the specific heat. Now, this is, again, an algebra problem. All right, we have to get this specific heat by itself. C needs to be by itself, which means we got to get rid of these values over here. All right, we got to cancel them out. So the way we do this is simple. All right, the way we do it is simple. The specific heat is being multiplied by 72.5, so we must divide both sides by 72.5. All right, and it's also being multiplied by 1,324, so we must divide both sides by 1,324. All right, let's plug this into the calculator. The specific heat is equal to 15,600 divided by the temperature change, 72.5, divided by the mass, 1,324. And we get as an answer that the specific heat of this substance is 0.163. All right, joules per gram that you raise up by a degree. So what this is saying is that for this substance, it takes 0.163 joules of energy to heat up 1 gram of this substance by a degree. All right, so let's put this in and let's see if this is correct. All right, 0.163 joules per gram Celsius. All right, joules per, I messed that up. Let's see. Joules per gram degrees Celsius. There we go. All right. And so what we could do is we could then take this value and we could consult this chart here. So this substance, it could be, it looks like it's some kind of metal somewhere around the range of tungsten and gold, but it doesn't match either of these. So it might be some other metal. All right. We don't see it on this chart, but if this were a real situation, all right, you could go online, or you can look up specific heats of metals, and you could find a chart here. Right, these things are all recorded. Let's see here, joules per gram degree Celsius. So we got, and again, this is extra. I'm not asking you to do this. This is just a proof of concept here. All right. So are any of these guys 0.163? 0.163. This is close. It could be liquid lead. 0.163, 0.163, 0.163. Let's see here. I don't see anything here that's specifically that. And again, this was oh, it's close to aluminum. I don't know what that is. Anyways, I'm getting off track here, okay? The point is that you could go online and consult different data tables and have some idea of what this substance is. Ooh, lutetium looks pretty close. Anyways, that's it, guys. That's this video. I hope this helped you. Thank you. Have a good day.